Hello,
Okay,
everybody.
good evening. Yeah, so we can set the stage. Harsh, you can go ahead.
Yeah. Hello, everybody. Welcome to the third session of IBC Continuation Education Program Module 2. Thank you for joining in. If any of your friends are yet to join, please just message them and tell them that we're starting. We have Mr. Selva Raju here with us again today to continue the Module 2 sessions. So without wasting any time, I'm going to hand it over to Selva.
Harsh. Okay, good evening, ladies and gentlemen. So first off, yesterday's session, I did give you some assignment, right? Did anybody try it? Did anybody try the assignment? Could not finish it, that's just fine, no issues, but if you have tried it, so let me know, please. See, it's imperative that you understand that until and unless you practice this, it will become extremely difficult or almost impossible to go to the next stage where you will actually be doing the build. Because as we go ahead, things will get more and more complicated. So let's see. So Abhinay, did you do that? Did you try it? Abhinay? Just type it in the chat window. What about you? We have Aishwarya, Smita, Suhani, and Udiana. Did any one of you try those exercises? Sorry. See, no responses coming up from your side. So I didn't try yesterday. We'll definitely do it today. That is Suhani. Okay. Who else? I got only one response so far. Other than Suhani, we have 5 more people, right? So any responses from your side, please? Response from others? Yes. So did you try that? You're saying yes. So by the way, yeah, Puneet, welcome. So Puneet, did you try the assignment yesterday? And Abhinay, what about you? Did you do that? Any success in writing the code and running it? Puneet says, I will do today only after the session. That's fine. So Abhinay, yes, little bit. What is that supposed to be? No, I'm happy that you tried. So that, see, that's the stepping stone. Okay, don't worry about that. Okay, right. Because I actually want to continue with the ownership and borrowing, because that's a concept that is something that you really need to get deep down into the details of it. So okay, so anyway, so what we will do here is we will take a little bit course. So let me share my screen. You want to see my screen? Are you able to see my screen? Yes, there's one request. When I ask something, please do respond immediately in the chat, because otherwise there's a total disconnect between what I'm saying and your response coming in so late. So I really do not know whether you are actually even attending it or not. So that sort of a situation comes up. Okay, right. So what we will do is create a new project. So say cargo new PEP session 3. And we'll go into that directory. And we will launch Visual Studio Code here. Okay. And also the previous assignment, I had told you to get the minimum from 4 numbers. I think that also remains to be done. So I expect you to do that as well, right? Okay. So let us now look a little get down a little bit further. So writing functions and parameters and mutations and mutable references and so on and so forth. Okay, right. So what we will do is, let's say I want a variable. So let's say I have let and signed 5, and I want to increment that, right? Now incrementing I cannot do because right now this variable is immutable. So the first thing I need to do is I want to change the value, then I have to make this as mutable. Okay. And what we will do is we'll write an increment function. So increment underscore, let's call this v1 for version 1. And what this does is basically it takes in x, which happens to be I32, and what it does is it returns an I32, all it does is it returns x plus 1. That's it. Now, so here what we're doing is we say, okay, find for calling increment and is and we give the value of and then we call the increment function. So one and pass in the value of n in there, and after calling increment, and okay, mutable reference, mutable variable reference of pointer, those can be used in the situation. And what we do is we say n is assigned increment of, okay, right. So now if I run this, I'm able to get this. If I remove this mute, then obviously I'm going to get an error because it's an immutable variable, it cannot be changed, right? So this, therefore it has to be mutable, then only we'll be able to do it. Now, just like we are using the increment function, this is v1 because this is the version 1, okay? So increment is there, okay? The other way, suppose I want to change, okay? So this is, let's call this as function as increment v2 is the second version, and somehow I want to modify the value of whatever variable that I have passed in, okay, which means it's not going to return anything, it will simply whatever variable you pass in, that should get modified, okay. So how to do that? So in order to do that, what we will need to do is that basically what we have to do is a little bit different. Okay, so what we have to do is something like this. I have multiple references x, which is a reference to multiple, and it does not return anything. Now, in order to call this function, so what I'm doing is I'm actually taking a reference to a mutable I32 value. Now, see this very carefully because this is completely different from the way you use, in other programming languages. So what I intend to do is, let's call this as one. And I just copy these two lines of code. Okay, so I'm going to call two. Okay, so how do I call this so that it gets incremented in here? So because you have to pass in a reference to a mutable I32. Whereas n is mutable I32. So what we need to do is when we call the increment function, you will have to call increment v2 like this. So suppose if I did it like this, I'm going to get an error. You see here, it says, hey, consider mutably borrowing here. Okay. So what you have to do is you have to pass in a mutable reference there. So say okay, reference to mutable. Okay. This is how you'll have to call. This is similar, to how you would do in C and C++, pass the reference, something like that. So what you're passing in is a mutable reference to n. Okay, and here it is receiving a mutable reference. Now, of course, you are getting this here because it is, if this is intentional prefixes with underscore, we are not using it. Okay. So how do I increment it here? In order to increment it, x is find x plus 1, where star is the dereference operator, just like you have it in C. Because you received a reference, to access the actual value, you will have to do a dereference. Okay, calculate the value and then dereference the pointer and then basically reference and then put the value over there. So let's see if this works. Okay. Now, I'm telling you, this is one of the most important concepts that you have to understand in order to use Rust effectively. Extremely important. So if you have any questions, please shoot questions as many as possible. Okay. Right. So let's just run this and see. See, now it has become 7. So it is working fine. So let me just do one thing for you. I'll just paste it in the chat window. I guess we should be able to. So you can just copy this, put it over there, run it and see. Okay. Maybe I'll just add one comment in there. Increments the variable input. It's not returning anything. It is actually doing the increment. So whatever data is passed in, that gets incremented, which means you have to pass in a mutable reference. Okay, this is very important. So, let's see. If you have any questions, please go ahead, please. But this part I want to take a little slow because this is something that you really need to master in Rust. Please. Guys, any questions? The code is right in front of you. You can actually look at it and ask if you have any doubts. The whole code. So honey, when you put an ampersand in front of mute, see, mute means mutable. Okay, ampersand if you put in front of it, it means mutable reference to a mutable. So is it a reference like a pointer? Yeah, you can think of a reference like a pointer. And in fact, some clues you can get if you see here. I'm using the dereference operator, right? Like you do with in C. So it's kind of this is reference means that it is a pointer. So when you dereference the pointer, you get the data. That's the value stored at that pointer. So as you can see here, if you see here, this is dereference. It's an operation. Dereferences the value. So what you're receiving is the address. So what we have passed in is a reference to mutable reference to n. Okay. You might ask, do I need to use it? Why not? I just pass in the reference to n. Okay. So if I did it like this, just pass in the reference to n by putting up the ampersand. Okay. And if I take this out and I just say like this, okay. So consider changing this to a mutable reference. See, here performs this process. Cannot assign star x, which is behind the ampersand reference. So now if I do it like this, is assigned x plus 1 like this. And what happens is performs the plus or see. Consider borrowing it here. Okay. So it is expecting. So expected due to this parameter type. Okay. So if you see here, it says okay. Expected. So whereas I found I32. Okay. So you could say something like this. If I say star x is star x plus 1, again there is a problem. Because now that means the reference needs to be mutable. Okay. So cannot assign to star x, which is behind a reference. Okay. X is a reference. So the data it refers to cannot be returned to because it is not mutable. Okay. So you can reference the value, but you cannot modify it. Okay. That is important thing. So that's why this whole thing actually will fail. So what you need to do is you have to this and make this as a mutable value. But because it's a mutable reference, we are passing in at reference to I32, but it requires a mutable reference. So now things are set up. Okay. So now I can see why we are doing it like this. Okay. Any other question, please? It's very important that you understand this whole concept. Okay, because this is central to understanding how Rust actually works. Okay, and if you see in the Rust book also, there is a whole chapter dedicated for ownership, references, and borrowing, and this slicer. Okay. These are something that you have to keep in mind. Okay. then ownership and functions. This is where the whole thing actually begins. Okay, so let us just take an example from here. So as I mentioned, so what happens is in many languages, what will happen is that if you saw the yesterday's, if you attended the yesterday's session, you would probably know what I was talking about. Okay, so in other languages, what will happen is basically when you do let S2 is assigned as S. So what will happen is you will have two pointers pointing to the same string. Now in the Rust, what happens is whenever a reference goes out of scope, whatever it is pointing to will also be deallocated. Now this is a typical problem. Now you see what we have done is that we have to understand this whole mechanism. Particularly, we use strings as our basic example. Okay, so I can just take so now we will do this step by step so that it becomes very clear to you. Again, remember, it's quite easy, not difficult at all. The only thing is you have to keep that at the back of your mind whenever you're working with the Rust. Okay, whenever there are reference types, things don't always work like what you are used to, and that's the reason I'm spending so much of time in this particular session on the ownership part of it. Okay, so if it is, let's say for instance, if it is C++, okay, we're using C++, and in C++, if I have just have string s1 is signed ABCD, something like this. Okay, so no, I should put semicolon also. So string s1 is ABCD. So what will happen is basically it is going to create a pointer, and this side is your heap memory. You have to understand memory management very clearly. Is your heap memory, and this is where our string ABCD is. Okay, and let's say this is at some address. Mention say 1, 2, 3, 4, 5, some address, and so that address is what is being held. Okay. Now at this stage, so far so good. So now if I create another variable, let's say S2, is assigned S1. This is our S2. Now, what actually happens is that in this case, this will also start pointing to. So this is called as the basically what will happen is that your string S2 is also holding the same memory. So inside of the heap, what happens is in C++, it uses a reference counting mechanism to see how many references are pointing at any point in time. Okay, so this is one of the problems. This is a problematic thing when what happens is if suppose when S2 goes out of scope, then it will try to deallocate memory here, and if that has happened, then in that case when S1 goes out of scope, there is nothing to deallocate because this memory has already been deallocated. So as a safeguard mechanism, what happens is internally in C++, what happens is it actually starts putting up reference counts. So it will keep counting as to how many references are actually pointing to this memory location, so that the memory leaks don't happen. So right now, at this stage, what will happen is your reference count is 2 because there are 2 pointers pointing to this location. Okay. So when S2 goes out of scope or S1 goes out of any one of these goes out of scope, when it goes there and tries to deallocate, it actually looks at the reference count. Okay. So if the reference count is more than 1, right now it is 2, right? So it will simply reduce the reference count and do nothing. Now, once S2 goes out of scope, obviously because you created S1 first and S2 later, so S2 will actually go out of scope first because of this stack placement. So when S2 goes out of scope, it's going to see what is the reference count. Is it more than 1? If it is more than 1, it will just simply reduce the reference count and leave it at that. So the reference count becomes 1. Okay. And then when S1 goes out of scope, at that time what it says is, hey, there is only one reference pointing, that is, it is me. At that point in time, only the deallocation will happen. Okay. If this reference count mechanism is not utilized, then obviously you will end up with double deallocation of the same area in memory, and that can lead to all kinds of runtime issues. Okay. So this is sometimes called as the copy semantics. That's what happens. Okay. It's called as the copy semantics. Any questions here, please? In second function, we are using mutable reference, and in first, we are not. Can you explain this why? Puneet, okay. No, it's just a mechanism of incrementing that I was showing you, that I can actually do an increment by passing in the variable and just returning an expression. That is again now assigned back to n. That's all. It's just a way of multiple. It shows different ways of actually doing the what to say increment. That's it. So the way you design the function will define the function signature and how it is actually utilized. Is it clear? all again depends upon your choice, how you want to do this increment operation. Okay. So in C++, this is how it is going to be, right? In Rust, what happens is, so let's look. Things work are a little different. Okay. So suppose, so let me just show you from the book also. It explains that clearly. So how the strings are handled. So basically, when you create a string, okay, just say let s1 is string.com hello. What it will do is it will create the string like this. So there is this pointer which is pointing to some area in memory, and also your Rust strings are not null terminated, okay, like C, C++. So in C and C++, if you put a null character anywhere in the string, the string ends over there, okay. So what it does is that when initially it creates this string in memory, okay, this S1 is actually a special structure type, okay. It works very differently. So basically S1 will have three parts. You have the pointer pointing to this, you have the length which will count the number of characters, and also the capacity. Okay. So this group of data is stored on the stack. On the right is the memory for the heap that actually holds the content. This is how actually the Rust string looks like. Okay. So what is the difference between length and the capacity? So length is how much memory in bytes. Okay. How much memory in bytes the contents of the string are actually using, and the capacity is the total amount of memory in bytes that the string has received from the allocator. Okay. So there is a memory allocator, right? So that allocator will actually, give you certain amount of memory. It will be at least the length of the string or even more. Okay. So the difference between length and capacity matters, but not in this context. So for now, it is fine to ignore the capacity. So you can just leave. So generally, what happens is allocator will allocate a little bit, a little extra, okay, compared to what you actually demand. So if you are creating string with these letters HELLO, which takes in 5 characters, okay, the capacity might be 10, but the length of the string is actually 5. This is so that you might have want to make changes without changing the pointer. Okay, suppose because if you want to increase the length of the string, okay, so strings are actually dynamic, so which means that you can actually increase the length. Okay, so therefore having some additional capacity will allow you to make use of it. Okay, guys, just give me a moment. Meanwhile, you can just look at this page and want to know more, you can just ask me questions. Okay. Okay, guys, I'm back. Yeah, Puneet, I told you that just I wanted you to stop for a moment. I had an important phone call. Anyway, okay. Right. Any questions, please? This is the representation of, memory of a string holding, hello, and it is bound to the variable f1. How do you create it? You simply say f1 is string from, and then give it a string. Okay. So, and after that, what we are doing is s1 is assigned to s2. So we will see what is the operation. So generally, what will happen when we assign s1 to s2? The string data is copied, meaning we copy the pointer. The length and capacity are on the thread. Okay, so we do not need to copy the data on the heap, and the pointers refers to. So basically, there's the conversation. Okay, so representation memory of the variable s2 that has a copy of the pointer. Okay, because essentially s is having, so it will take the copy of the pointer and point it over. Now, the representation does not look like figure 4.3, which is what memory would look like if Rust instead copied the heap data as well. Okay, the heap data itself is to be copied. So now, again, remember, this is what if Rust did this operation. This is if Rust actually did it, which it does not. Okay, so then in that case, the scenario would look like this. S2 is a completely different string. Okay. Now, the problem why you don't do it like this is because if you want to do it like this, what you will have to do is the entire heap data you are seeing here, okay, from S1. This will have to be copied into another location in heap, and then the allocator will have to be called and get the allocation done, copy all the data, and then put all these values populated here in S2. Now, this is very expensive. It's actually very expensive operation. Not to mention, it is also wasteful because you're simply repeating the same data. You might as well be more efficient if you did it like this, where you are only copying the pointer, okay, and therefore, essentially pointing to the same location, whereby you don't copy the entire data. Okay, right? Now, you see why it does. So earlier we said that when a variable goes out of scope, Rust automatically calls the drop function and cleans up the heap memory for that variable. But figure 4.2 shows both data pointers pointing to the same location. See this 4.2. So what will happen is when S1 or S2, so this is known as a double free error. Okay. So you see, so figure 4.2 shows that both the data pointers pointing to the same location. So there is a problem. When S1 and S2 both go out of scope, they will try to free the same memory. And this is called as a double free error. And is one of the memory safety bugs. Okay. And so freeing memory twice can lead to memory corruption, which can potentially lead to security vulnerability. Okay. So to ensure memory safety, after the line let S2 is S1, Rust considers S1 as no longer valid. Therefore, Rust doesn't need to free anything when S1 goes out of scope. And check out what happens. So basically, this is what is actually happening. Okay. So we can actually test this out. Okay. And you will see that the number. So what actually Rust does? Okay. You heard of the term shallow copy, deep copy while working with other languages. Okay. The concept of copying the pointer length and capacity without copying data probably sounds like making a shallow copy. But because Rust also invalidates the first variable, instead of being called shallow copy, it's known as a move. I told you, right? Move semantics. So actually, if there is another problem with these mechanisms, and these mechanisms is that suppose this is actually kind of a shallow copy. Shallow copy would mean you are just copying the pointer and not what it is pointing to. So the shallow copy itself has all kinds of issues. Even it is the same thing that you have to consider even in C and C++ as well. Okay. So by the way, do you know the difference? Have you heard of the term shallow copy and deep copy? Shallow copy and deep copy. Deep copy also takes the address. Okay, so let me explain, because this is central to understanding how Rust actually behaves. So essentially what happens is, if you want to understand, say basically what happens is, shallow copy looks like this. Okay, you create a variable. Okay, variable. So let's say this is some variable. X, and let's say if these are strings. Okay, let us take string itself. And we create this X and we initialize it with some values, let's say uh, hello, like this. And this is 1, 2, 3, 4 is the address. So basically this contain 1, 2, 3, 4. Now, if I create another variable, say if I say so, what we're trying to do is something like this. Say I say y is assigned x. Let's not get into any syntax stuff, because this is completely language agnostic. Okay, we're just understanding the process in this. So in this case, what happens is you have y and this is shallow copy. So what it happens? So what actually, when you are creating, let's say, a string, okay, so basically string is going to be allocated in heap, right? And that heap memory, okay, wherever it has been allocated, that address is what is actually stored in the variable x. Okay. Now, important thing. Oh, by the way, Harsh, the participant can unmute and speak, right? Can they unmute and
No,
speak?
no. So we have not given that option. Do you want us to give that
Okay,
option?
okay. It will be better so that they can speak.
Okay.
Can
Harsh,
ask
can you do
questions.
that, please?
Give more interest.
Harsh, can you allow that?
I don't see Harsh there.
Okay. I'll check with him, sir. Please carry on. I'll check with him.
I think there is this option allowed to talk, but
If you can see the
but,
option. Yeah.
but
So guys,
that is
let's do one. Raise your hand and we will allow you to talk.
that will be better. Okay.
Yeah. Yeah. So Salma sir, if you see a hand, you can just allow them right away, or whoever sees it, we can allow it right away.
So you can enable that. Okay. So
Yeah, yeah, we
that I
can.
can
Anyone,
concentrate
you
on.
also, I also, anyone can enable it. Yeah.
So if you have any question, you can just raise the hand and you'll be unmuted to speak. Okay. So I don't see any. So what is actually happening? So even though we are defining X as a string, so basically it's a pointer or a reference. So what will the data in X be? It will be a pointer only, right? So when you say when you take X and assign it to Y, what are you copying? You are basically taking what, see, assignment, what does it mean? When I say A is assigned B, the value in B is copied to uh, the A or something like that, right? So essentially you are getting, so what is the value of X? The value of X is actually 1, 2, 3, 4. That's the content of X. That's what it is actually storing. So that's what gets copied here. Okay. And so essentially now what you have is a shallow copy. Okay. So you are not copying the actual content. You are only copying the reference. Okay. This is called as shallow copy. Shallow copy always has this problem that when these variables go out of scope, and whenever a variable is going out of scope and you want to deallocate what it is pointing to, you will run into the double deallocation error. That can lead to all kinds of security vulnerabilities in your code. Okay. Now, if you have shallow copy, okay, so on the other hand, this is, let's say, deep copy. Okay. If you are using deep copy, then what will happen is something like this. Okay. You will have this situation. So basically, this is the difference between deep, shallow copy and deep copy. Okay. Actually, deep copy is a very complex mechanism. Okay. Because you know what happens is even when you do deep copies, you can actually run into problems. Okay. That is something that I will show you in a little deeper. So basically what you do is when your language is supporting deep copy and you do the same operation, this time around what will happen? A new variable y, when it is a y is assigned x, what you are essentially doing here is that whatever x is pointing to, that data will be copied. Okay, a new copy will be created. That is at a new address, and that address is what is actually getting stored into y. This is called as the deep copy. Okay. Now with deep copy, what happens is you don't run into the so-called uh, double freeing error, because when y goes out of scope, it deallocates this area, and when x goes out of scope, it allocates this area, and so therefore this is a very safe mechanism. However, the downside is that it's very expensive. Expensive in a sense, imagine this is a string with just 5 letters. Okay, let's assume that you had a mathematical problem which you wanted to solve, and you wanted to create you have an array of, let's say, 100 by 100, which is that like 10,000 values. Imagine if you do this deep copy, what will happen is essentially you will have another set of 10,000 values. All that data needs to be copied in memory. The allocator has to work hard to actually allocate that much amount of memory, and then all the memory management has to be carried out. And so CPU cycles will be utilized in order to carry out all of these activities. So this becomes expensive in terms of time, in terms of efficiency, as well as in terms of space. Okay, so the deep copy has this issue. So for simple, small values, that's just fine. But if this is a huge array, like say, for example, a million values, imagine doing it like this, what will happen? You'll soon run out of memory. So this is the kind of issue that you will run into when you do a deep copy. Okay. Right? So this is deep copy. So let's do one thing like that. So this is deep copy. Okay. So Deepak, can we have a small break here?
Yes, sir. Sounds good. I'm seeing one hand here, Puneet. I think let me just allow him to speak.
Yeah.
Yeah, Puneet, go ahead, bro. Okay, I think the permission is. Yeah, I think now you can speak, Puneet.
Your screen is not visible, sir.
Screen is
Hello?
not visible?
No, sir. Screen is not visible.
Oh. It's visible now?
No, sir.
No, sir.
I think now it should be visible, right?
Yes, sir.
Yeah, now
Yeah.
it is. Yeah, Puneet, is there a question, bro?
No, sir. No question. I was telling this only.
Okay, no worries.
Okay.
Okay, so Salva sir, we
I
can
didn't feel it.
yeah. So it's 8:12 now. We can meet at 8:20.
Sure.
Yeah. Okay.
Okay.
Guys, we'll catch up again at 8:20.
shall we resume?
Yes, sir. Let's continue. I'm seeing another hand.
It's
Achha, okay, it's of it's the same person. Okay, yeah, sir. Let's continue. You can share your screen.
See my screen?
Yes, sir.
Okay. So this is, so you understand now what is shallow copy and deep copy is. The other mechanism, which is what actually Rust uses, is called Rust move. So essentially, now what will happen in this case is, okay, that you create a string variable and you have stored hello in there, and when you do this assignment, okay, then what happens is, so basically a new string in heap is not created. Instead, and this is the 1, 2, 3, 4, and our x is invalidated. Okay? Not pointing to anything. Okay. So invalidated point. So which means that it is not pointing to anything. So basically this is where ownership comes in. So when you do an assignment like this for the string, what happens is you have changed the ownership from F to, hey, you know what, hey, why you take the ownership of the string that I'm pointing to. This is called as move. So basically the ownership of this string hello, which was earlier held with X, is now moved into Y. Okay. So this is called as the move semantic. Okay. And this is very safe. Now, what happens is, if we use this sort of mechanism, then what happens is the big advantage here is that when suppose y goes out of scope, it actually is pointing to this location, so this location will be free. And when x goes out of scope, it's already invalidated, so there is nothing to dereference. I mean, sorry, to deallocate. And so the memory leak related issues, double dereferencing, double deallocation, all those problems are avoided. Okay, this is how Rust actually handles. So this is natural syntax. Okay, now this sort of thing is available in case of C++ standard template library also, but then you have to use specialized, so-called smart pointers in order to make use of it. Okay, whereas this is something that is actually built into the Rust core language itself. So every time you have reference types, okay, so when you assign them, you do not get shallow copy or deep copy. What you get is change of ownership from the source onto the destination. So this completely avoids memory related issues due to double deallocation. So because there is no double deallocation happening anywhere. Right. So in Rust, this is what happens, and you can actually see this also. So let's say I create a string, okay, let's say S1, S1 is assigned from hello. Okay. And and then I print it out. This one is and let's run this and see. So S1 is hello, right? Okay. Now what I do is I say let S2 is assigned S1 and then I print this again. Immediately you'll start seeing the power. Okay. And let's just print one more time. Okay. Now you can see the error here. Say borrow of moved value S1. So value borrowed here after move. This is what is happening. So here, what has happened is ownership of string is moved to S2. Okay. So what will happen is, so S1 is no longer valid. That's no semantic. So, therefore, this will not work. Okay. S1 is invalidated due to okay. So this will not work. Okay. Let me put this code in the chat window also for you guys. Right, so you'll get an error there. Now, the same thing happens even when you're using functions as well. Okay, so let me just show you. So suppose what I do is I create a string. So let S1 is find string from hello. I have another function display string, which takes in a string. So let's say S is string, and we're just using print line. That's all. Print line. So string is And now, first I print it here. Print line S1 is right, and then I call the display function. Okay, display string and S1, and I use print line again as a after calling display string. S1 is S1. Okay. See, the same problem happens. Borrow of moved value S1. And in fact, let me just compile and show you here. Okay. See. So S1 string dot from move occurs between S1 hash type string, which does not implement that copy trait, so that's fine. And then you can do the S1 so print is fine. This is string. So value moved here, and then the value borrowed here after the move. So therefore, this is not going to work. This won't work because when you pass this string into the display string function, what has happened? So basically, what will happen? Move will happen. So S becomes the owner of that string. So S1 becomes invalid, right? Therefore, you cannot use S1 to display any data because it's no longer a valid pointer. No longer a valid pointer. Now, this is something that you have to keep in mind. Okay. So, because of that move, okay. Won't work due to move. Function call to display. Okay, so this is something that you have to keep in mind. Okay, so the move semantics actually has this sort of an issue. So how to get rid of this problem? So what we will do to get rid of this problem? So first, this is our problematic code. I'm going to put this up in the chat window. And then on the support. So what we can do is we can pass in the reference to this thing, right? So I can pass a reference to the string here like this. Sorry. Okay. So when I pass this reference, it says, okay, consider removing the borrow. And here, what we do is, here's a reference to this. And now see that error is also gone. Okay. So now you can see. Okay. S1 is hello. Your string is hello. After calling display string, S1 is hello. So S1 did not get changed. So what did you do basically? So instead of passing in the string which would have moved, okay, so what happens is we are passing in the reference to this thing. So basically your S is again a reference. So it is actually pointing to the original string. And also because it is immutable, it cannot make any changes to the string. Okay. So you have multiple, okay, references to the same string now. So here S1 is already a owner, so it is having a reference to that string. When we pass that, so S also has a reference to the same string. Using that reference, we are actually displaying it. Once your display is done, and then we come back up here, and then so basically when S goes out of scope, okay, it's just a reference, right? It's an immutable reference, so it does not have any capability to change the string. So therefore, what happens is it just comes out, and there is nothing to it's an immutable reference, so it will not do anything. So it will simply go out of scope, and only S will get destroyed, not the string. And when you come here, S1 because it's the owner, so when S1 goes out of scope at the end of the function, at that time only your main string is going to get destroyed. Right? Okay. Now, you can have, say, for instance, suppose I want to make changes to the string. Then what do I do? Okay. If I want to make changes to the string, so that's our next piece of code. You can just copy all the code snippets and put it there. Okay. Put it for your reference. So I can't change the string. So suppose I want to make the string capital or do something like that. Okay. I can't do it. So what I need to do is to change the string. So obviously what you will need to do is that you need to have a mutable reference. So that means this string will also need to be mutable. Okay. So it's a string. Okay. Okay. A mutable variable reference or a pointer. So whereas what happens is this string, okay. So mutable reference. The reference for mutable. The result allocated is on heap except for string. Okay. Now, suppose I want to make changes to the string. Okay. Sorry, that's wrong. So if I did something like this, let's say h1 dot push second or h1 dot shift here. Okay, and then okay, so now see what happens. Cannot borrow S1 as mutable as it is not declared as mutable. Okay, so I'll define this as mutable string. So now I can actually mutate the string. So our S1 is a mutable string. Okay, right. So now if you display this, things will work just fine. So this it has become hello world, hello world, hello world. So everything is okay. So you can create mutable strings like this. Okay. Now suppose I want to change this string inside of a function. Okay. So let's say I want to create another function. So this time around, let's remove this function. We don't need it. So we'll just right and say s. Okay, and then here what I do is I say s dot to uppercase okay call the capitalized function, and now I have to pass in a mutable string, so s1. Right. So now let's so what happens? Mutable variable reference pointer mute can be used in several situations. Variable does not need to be unmutable. Okay, so remove the mute. Okay, so I'll just remove it. Now what happens? Okay, so let's see. So what happens? Could not compile due to process. So what is that? Let mute S1. So move occurs within S1 has type string, right? Which does not implement the copy table. So when you pass in, when you say S1, so S1 is no longer valid, right? So we cannot do this. So what we want to do is we want to pass in a reference to that. Okay, we're passing a reference to that, which would mean that I need to do a reference to this. Okay, if I put in reference to this, okay, I'll still have a problem because I've received a reference. So basically, this reference is an immutable reference. So here you'll see that returns uppercase equivalent. Okay, So basically the problem here is that you are trying to modify the value. Okay. Modify the value. Okay. So what we need to do is we need to pass in a mutable reference here. So I say I want to pass in a mutable reference S1. Okay. And this also needs to be mutable reference. Okay. Return surface equivalent I will define. Oh, it returns a string. Okay. So it will return, it will not do a modification. So let's say, okay, I wanted to change. Okay, so let's say let's call this as add word. Okay, so what we're trying to do is we are trying to add the word world into the original string. Okay, so I'm receiving this. Okay, is a reference to unvetable string. And then I say s dot push here, and then I add okay. So now okay, after calling it has become S1 is hello world. Okay, so let me just okay. So lot of code in here, right? For your reference. Okay. Now what we're going to do is to understand some basics of the mutable and immutable references. So let's say I have a string. Okay, let S1 let S is assigned string from So I can actually create, references right out here itself. So say I'll say let R1 again it's a reference. Okay, assign address of S. Okay, right, and then I say let R2 is address of is so reference to S. Okay, I can see here. What are the oh, we are not using, so actually I'll just add this annotation. Right, okay, right. Now we are having two references pointing to the same string. This is fine. Okay, right. And now let's say, can I create a mutable reference? So let mute. Oh, just keep it simple. Okay. Let S2 find thing from something like this. I want to create a mutable reference, so I'll say let mute mutable reference MR1 is assigned to address of S2. Okay, I'll try to create a mutable reference. A mutable variable pointer can be here. This expression has the type refers to mutable. So what I need to do is I can create a mutable reference. Okay. Cannot move out of a mutable reference. Why is this so? That's because move occurs in MR and type string, which does not implement copy paste. So this is a problem. Now see, I'm taking a mutable reference, whereas which means that through the reference I can change S2, right? So this is not allowed because our string is not mutable. So what I need to do is I can make the string mutable and do it like this. Oh, cannot move out of a mutable reference. Okay, data moved here. Move occurs because MR1 has a type string, which does not implement. Okay, so considering removing the from MR1, so if I remove this, so our MR1 is basically mutable reference. Okay, right. So I'll create one more mutable reference. Let MR2, okay, is assigned address mutable reference to S2. Okay. Right. So You are creating two mutable references. Now, so this kind of situation you will definitely run to where you have multiple mutable references. Okay. Now, let me just show you from the Trustbook what this is. Okay. So I'll just show you the code. So they've given a little bit of example there. So I just okay, create a mutable string. Okay. And then you create a reference to this, put it in R1. So this is immutable references. So no matter how many number of times you want to do it, you can do it. R3 is actually mutable reference. This is a big problem. What happens? Immutable borrow occurs here. So once the immutable borrow has occurred here, okay, again a mutable borrow cannot be turned. Okay. When you combine mutable and immutable references, okay, you will run into this problem. The combination of mutable and immutable references to the same string. Okay. And here also the same. So now this is a mutable string. You're creating this address of you're taking reference to S and putting it R1 and then putting it to R2. This is what just happens. The moment you put a mutable reference to S, okay, you'll then see what happens. So variable R1 R2 will not be used here after this. Okay, because you have actually passed them into the print line macro, so they will be used up. Okay. So what is the basic difference? If you see this code and this code, okay, it's actually literally the same, but there is one big difference. There is a print line sitting in here. So when that function runs, so basically the ownership has gone to R1 and R2. Ownership R1 and R2 has gone into those. So after this, R1 R2 will not be used, right? They will become invalid. And therefore, now when you create a mutable reference, there is no combination of mutable and immutable references at all. So in this scope, so therefore, this works just fine. Okay. So this is something that you have to keep in mind. I would recommend that this chapter 4, please read this from the book. Okay. So at the end, you see the rules of reference. This is something that you have to keep in mind. Okay. What is that? At any given time, you can have either one mutable reference or any number of immutable references. Okay. Any number of immutable references, or you can only have one mutable reference. Okay. And the references must always be valid. So these are the two rules that you have to keep in mind in order to really understand all of this. Okay. So please read through this chapter 4 of ownership. It will take you a little bit of time to understand. So just try these code snippets, and you should be good to go. There should not be any problem. Okay, but remember, you have to do this a couple of times in order to be able to perfect this. Okay, right? And this is important because this ownership model actually makes Rust pretty different from other languages that you might have actually used so far. Right. Therefore, you need to keep that in mind, because whenever you're writing code, you need to ensure that everything works smoothly without any issue. Okay. So let me see. Is there any question, please? Puneet, I will still recommend that you read that chapter 4 from the Rust book. Okay. And guess what? There's one more advantage of this. That is, if you see here, I think probably see here itself, you can copy to the clipboard and then you can basically show the hidden lines, and you can actually run the code also here. If there is no error, you can just run it right away on the web page itself. Okay? There is no output. That is fine. Okay. So please read through it, and I request you to finish the assignment. Today I'm not giving assignment because I'm still waiting for the previous assignment. Okay, for you guys to submit. Okay. Okay, guys. So that's it from my side. Okay. So see you on Monday then, right? So Deepak, we have the next session on Monday, right?
Yes, sir. And today we have a quiz also. So what I'll do is, sir, we can end the call, but I'll just share the link over here in the chat. So the students can complete that and submit it. So it's 9 now. I'll keep it open till 9:30. That works, sir?
So I can drop out of the call, right?
Yeah, we'll end the
Or
call.
you want to-
I'll just
Yeah.
we'll
Okay.
end the
Okay.
call.
So you are giving
Just
the
share.
okay. You are giving this. They can do it offline, right?
Yeah, they can do it offline. Yeah.
Yeah. Okay. Fine. But guys, 9:30 it will close. So which would mean that by 9:30 you have to submit it. Okay.
Right.
Okay, guys. Thanks for your patience, and I'm very happy at least that even on a Saturday you people turned up. Okay. So I'm very happy for you guys. Just keep this momentum going. You might find some topics, a little difficult to understand, and what to say. But then it's all part of the learning journey. Okay. Initially, you will feel it like that, but as you keep working on that, let me tell you one thing. You do the assignments as I say. I'm telling you, your understanding level will go to a different level altogether. Okay. So please bear that in mind. And Monday, I request everybody to submit the assignment. Okay. At least show me that you have done it. Okay. Okay, guys. So thanks for your patience. So Deepak, are you sharing the link?
I've shared the link, sir. You can sign off.
Yeah.
I'll wait for a few more minutes just to make sure that everybody, uses the link. Then I'll close the call. Thank you, sir.
Okay. See you guys. Bye bye.
Bye. Robert Duck. Okay, guys, I'll be ending the call now. Kindly use the quiz link and submit it on time. Thank you all.